Hey, Aaron Rabinowitz here for Red Giant Software. Recently, I did a tutorial for Red Giant TV called Creating a 1980s Retro Video Game Look. I covered a lot of cool, and by cool I really mean nerdy, stuff that helps you save time and to create the vector look so popular in the early MTV age. But maybe you didn't want to sit through an hour-long tutorial. Yes, it really was that long. Or maybe you watched it and want to know how you can use those concepts outside the range of creating a vector video game look. So, in this Red Giant quick tip, I'm going to revisit one of the expressions that I covered there, and I'll show you how you can use it to go from the 1980s to the 21st century. So in that tutorial, we created a whole bunch of elements with Red Giant Plain Space, and you can find, if you've got Red Giant Plain Space, you'll find those tools right here in Window, and there's a whole bunch. We used the spheroid creator to create this sphere that you're seeing here, right? And what we did was we made all of these pieces children of a null that we sat at the center of the spheroid. And over time, we scaled up the parent, the null, and these layers all moved away and they rotated and a whole bunch of other stuff that we had set up, and also to lose their opacity. But I want to concentrate on the scale for just a moment, because what's really interesting is that as the parent is scaling up, in order for these layers to stay the same size, they have to inversely scale down. So what we did was we created an expression, and we'll just take a look at that scale expression, which basically says that it's going to take the actual value of scale for this asteroid piece, right? And it's going to multiply it by 100. And then it's going to divide it by whatever the parent scale is. So at the beginning here, where everything is 100%, so the layer's original scale, even with the expression off, is 100%. And we multiply that by 100, and we get 100 times 100 is 10,000. And then the parent scale is 100, so we divide that by 100 and we get back to 100, because 100 times 100 divided by 100 brings us right back to the original value. But what's really interesting is if I were to set this value up to 200%, right, our null is going to be scaled up 200%, the pieces move away, but notice what's happening to the values. As this scales up to 200, because it's double the original size, this one goes down to 50. So we're basically saying 100 times 100, right? And that's 10,000 divided by 200, and that comes out to 50. Okay, so that's how we did that, and we're going to use this now in another project. Okay, so here I am in another composition, and I've got 8 solids. They're all different colors, and I want to create an arrangement of them. Basically, I want to create a matrix of 4 by 4, and I can sit here and do this individually if I wanted to. But a very fast way is let me select all of them, make them 3D, and I'll choose Window, and I'll go with Matrix Creator Light. Just use the light version, and we want to have our matrix be 4 by 4, so a total of 16. And for the record, these solids are all about 30 pixels by 30 pixels. So I want to give a little space between each solid. So I'll set the grid space to 50 by 50. So each layer will occupy the area of 50 by 50, and there'll be some space around it on each side. So we have some space between all of them. I'll also tell it to repeat the layers. I'll say repeat them twice, because if we're going to 16, because 4 times 4 is 16, we also have to keep track of the fact that there's only 8 solids here, so it does need to repeat them twice to fill that 4 by 4 grid. Okay, and I will click on Apply, and there we go. We've got our nice grid here of 4 by 4. And let me close this out. And I'm going to add in a new null object, and I'll also make that 3D. And again, I'm going to make these all children of the null. Okay? So right now, if I were to scale this up, as you can see, what happens is all of the layers scale up in size. They do move away from the center of the screen, but they actually are moving away while getting bigger, so it kind of just seems like the whole thing's really just scaling up. And what I want to do is repeat what I had there before, which is to make them scale down as the parent scales up. So let's see if we can't just quickly recreate that. So I'll select this first solid, and I'll hit S to reveal the scale, and I'm going to Alt click on that to create an expression. Let's just give ourselves a little room to work with here. and I'll type in S. So I'm defining a new term called S, and I'll say S equals, and we'll say S equals the transform scale, and I'll say 0 because X is 0, Y is 1, and Z is 2. So we're saying S is equal to the X scale, right? And I'll just say 100 times that X scale, right? And then I'll say divided by, and again, I'm just going to type in the word parent, and I'll just grab again this this value. So parents transform scale 0. I just wanted the word. I didn't have to grab it from here. I could have grabbed it from anywhere, but if I had grabbed this from anywhere, it would come out to be a much bigger expression and I'd have to edit it out. So let me just show you that. If I were to grab the piece from this X scale, it would say this comp layer null for. I don't need that. But what I will do is I'll just delete everything that I don't need. And so we're saying 100 times the scale value divided by the parent scale value, and the parent is our null for. Okay, with that done, I have to finish the definition of a term with a semicolon, and then I'm just going to create an array that says S, 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 which just means apply the value of S to X, Y, and Z. And let me just close our bracket, and that should do it. So now as I scale up, as you can see, if you keep an eye on this particular square, it stays the same size no matter what I do, which is great. So what I'd also like to do is then copy the scale property here, and I'll choose Edit, Copy Expression Only, and I'll select everything, and I'll choose Edit, Paste. So now as I scale, they all move away without changing size. So as you see me playing around with this and making something that looks kind of like a Rubik's Cube, you may be wondering when we're getting out of the 1980s as promised. Well, if you've been following me on Twitter, you probably know that Red Giant Software is about to release a new iPhone app called Plastic Bullet. Who knows, by the time you watch this, it may already be out. But when I record this and when I put it up on the web, it won't be. Anyway, this is my current Plastic Bullet gallery. Now, Plastic Bullet gives your iPhone the ability to take pictures like it was a cheap plastic toy camera, kind of like the Holga. And it really creates very interesting results that are very beautiful and often very unexpected. So I'm working on a commercial for this just to really basically explain how it works and just to show it to people who are prospective buyers. And it occurred to me that I could save a ton of time if I use this expression. Because while that Rubik's Cube looking thing maybe not the most practical motion graphics elements you've ever created, it does set itself up in that 16 by 16 grid that is an awful lot like the iPhone's icons. So again, I've got my null scaling up, and I've got each of these different icons that are all using the same expression we just covered. And as I scale up, they all move out without scaling down. So it makes, if I have to do a lot of this kind of animation, it will save me a ton of time. Anyway, I hope that this quick tip helps you in your work, and I strongly encourage you to check out episode 39 of Red Giant TV, because while it's focused on creating a retro vector look, it's full of a lot of great information that will help you work faster on any project. Once again, I'm Aaron Rabinowitz for RedGiantSoftware.com. See you next time.